the more force is needed to achieve the same rate of change in motion. So if I can have one person from each table come up and get a few books for their table, go ahead and choose someone and come on up over here. At each station, you will find a handout of the lab. And it got cut off, but I wrote it down. At the top, there should be a heading for the observer of the group, the demonstrator, and the recorder. Remember that those roles you each have to take on, volunteer as you wish. Make sure to label your name next to what role you're playing in each lab, okay? Follow the directions as given on the handout, and I will be going around and answering questions. For the first one, books versus books, you just got your books right here. You're going to be using 2 for one of them and 3 for the other to do it, okay? Or you could also do 4 and 1, however you like, okay? And then the next lab we'll go over as soon as you're done with books versus books, okay? So go ahead and get started and read the directions.
Well, I don't know, that could also be yeah. Well, I mean, always like that. And then we have to push that to the
So who's the demonstrator here? Okay, so you're going to be pushing the stack to the middle of the table, to there, okay? Who's the recorder? Yeah. You might want to actually choose this side since they're going to be there.
Okay, we tried it.
Oh, you tried it?
Okay, so we just have to.
Mm-hmm. So we saw what we did. Who's the observer? Yeah. Go ahead and describe to them to observe so that they can illustrate. You could also vary it and try with just 4 and 1. Try with 4 and 1. Since it's heavy, what is your arm
Energy. They're what I meant. Listen to this.
So as soon as you get done with this, go ahead and start filling out. Alright, everyone seems to be done with the books versus books lab. So go ahead and answer the following questions on the next page, okay? Give you about 3 minutes.
I was thinking that.
No, talk about like what we talked about with your arms.
Oh yeah. More
Okay, just take another moment. You'll have some time after class to finish that up. We got to move on to the next lab. All right, so we're going to move on to the next one. There's another handout at your table called Taking a Fall. I'm going to need one person from each table again to come up and get some supplies for this one. So at your desk, you should have a box. Go ahead and open that box. Be careful though, there's flour in it. Don't tilt it, it might fall over. So there's flour. Some of it might have shifted to the right, to the left. Go ahead and give it a little shift so that it's nice and even, okay? Make sure to shift it away from your eyes or anyone else from your group. And you just want somewhat of a level surface. Okay? Alright. And you also have a ruler, correct? Yes. Okay. And then these three objects I just gave to one of your team members. Again, you're going to be taking on those same roles. I'm sorry, on my handout, again, it got cut off. But you're going to have an observer, a demonstrator, and a recorder. You can switch up the roles if you'd like. So basically, you're going to read the directions, follow them, and then illustrate the experiment, okay? And I will go around and ask questions.
So you're gonna stand up, like I said, you can stand up. Like you need him. You're gonna drop it. You're gonna drop it three.
Where'd you drop off?
Yes, on the floor. But at the same time, the same height. Okay, wait. That's not the same height. Okay. Okay, hold on. 1, 2, 3, go. Oh my god.
That was really cool.
Okay.
That was really cool.
Do you wanna try it again?
Alright, but that's a bit too.
Right here. This is a napkin. Wait, do we have to measure? No, it doesn't say that.
Dang, flower bounced all over the place.
Do we have to measure, like, what is it?
Yeah, basically that's what the ruler is for, so that you can structure, the crater.
Oh, okay.
Okay, cool.
In inches? You want to measure that?
Just analyze the differences between them. What are you noticing, Miguel? The measurements.
Bigger objects don't go as deep. Like the more depth objects.
You guys can do this a few times to justify, you know.
I think that's good. Yeah.
You guys do it.
Okay, 1, 2, 3. You guys do it? I think that's something different. Same time? Yeah, at like the same time.
Keep messing up between
Two, 3. Oh, because it's light, it doesn't go.
What was that?
Because it's really light, it doesn't go.
It's roughly the same size. Well, it's kind of in between the marble
Yeah.
rock, right?
And then
It's huge.
the rock has more surface area, so like really penetrating. Like pounds per.
Also, the paper, it's like in the air, like it's too light that it stays in the air.
Oh, yeah.
That doesn't have that much of an impact.
That's more drag.
How are you guys doing?
That one,
Oh wait, no, you're right.
heavier.
You want to drop that?
Here,
You want to try?
One, two, three.
When we finally released them.
Why or why not?
Are you guys analyzing the craters?
Oh, yeah.
This
one has me. Sure.
On 3.
It's a huge bladder.
What do you think?
Because it has more heavier. And it's heavier, so then it sinks more into the flower than this one. This one's too light. It barely makes a picture.
Good analysis.
Thank you. Where's down? Valuable. Did they? Yeah, this one. Like this one makes like a huge indent, while this one doesn't.
Did all the objects fall at the same time? No. Very slightly.
I guess not exactly. The paper had more drag, yeah.
This one has more mass. More indent.
Why did it do that? Because of what? Okay, by now you should have conducted the experiment a few times. Go ahead, sit with your group and discuss the questions, okay? Oh, please place the material, you can just put it all in the box so that flower juice will go on over.
Yeah, they.
So this was like safe to analyze for craters. You didn't have to write anything down. It was like, oh, like the vision given number.